Okay, in today's section, 2.4, we're going to cover parallel and perpendicular lines. Today's part, we're mainly going to be focusing on the first goal here, creating equations to represent lines that are parallel and perpendicular to a given line. Now, before we really get into parallel and perpendicular, creating the equations, we probably should make sure that we have an understanding of the difference and characteristics of parallel and perpendicular lines. Okay? Spell would be all right. There we go, perpendicular. There we go. Now, parallel lines, two things. And there's going to be two things for each of these, but we're going to address parallel first and then come back to perpendicular for the final examples dealing with that one. Parallel lines, okay? Lines never touch. Once again, I think from today we've seen a lot of students are able to understand parallel lines, so they know that they never touch. They're going to keep going and on and on and on and never intersect. Now, the other thing that we need to understand, this is the one that students have a little bit tougher time of understanding, is the slopes of parallel lines. Now, the slopes of parallel lines, we can visualize two lines vertical, up and down. And we ask, what's the slope of each of those lines? And of course, vertical lines all have the same slope. They're all undefined. And then we maybe say the same thing about horizontal lines. Let's say we had two horizontal lines here with my pens, okay? And I would say what the slope is, okay? The slope is 0 for each of those because all horizontal lines has a slope of 0. So basically, all horizontal lines have the same slope. All vertical lines have the same slope, which means it goes to show you, since all vertical lines are parallel, all horizontal lines are parallel, that means the slopes of parallel lines are equal, okay? It doesn't just apply to horizontal and vertical lines. Even if we had 2 points right here with my finger and the pinpoint, and the slope of each of them was 2 over 3, up 2 units to the 3 right units, up 2 units to the 3 right units. So it follows a pattern, kind of like a staircase does in maybe someone's home. So parallel lines have equal slopes, okay? Parallel lines have equal slopes. Now let's go ahead and address that in these two examples here. Now what they're asking us in these two examples is to create the equation of the line parallel to the following that also goes through a given point, okay? Same thing for both of these. We're going to start with the one on the right here, and what we want to maybe address first is the slope of this line. Now this is in y equals mx plus b form, even though it doesn't have a plus or minus b at the end here, or a plus or minus a certain number. Remember, anytime we don't have a y-intercept visible like this, we could always kind of treat that as a plus 0, which means the y-intercept is 0, goes to the origin. Now mainly though, we are going to look at the slope here. The slope of this line is negative 2 over 3. Now we want the slope that is parallel, okay? That was a key word in the instructions here, parallel. Both of these are dealing with that, to the original slope. We want the parallel slope. Now we will have a symbol for parallel, and no, it is not a number. Yes, it does look like 11, but it represents two vertical parallel lines. So if we were asking for the slope of the parallel to this, once again, slopes are equal, so if this is negative 2 over 3 for this equation, we want to use negative 2 over 3 for the new equation that we're about to use. Okay, once again, they should be identical to one another. All right, in which case we're going to go ahead and use the point that they gave us here, this negative 3, 5. And since they gave us a point, we found the slope to be the same. Point slope form should be what we were using here. Remember, that is the y minus y sub 1 equals m times the quantity x minus x sub 1. In which case, this is our slope, and this is our point. If we need to still do, we can label it x1, y1. So let's go ahead and plug in our information here. We have y minus the y sub 1, which is 5, equals m, which is the negative 2 over 3. Now, I know these are the exact same thing, but we always want to reference the slope of, it has a symbol, either parallel or later when we talk about perpendicular. All right, we never want to go back to the original. We always want to be looking at the new one. Once again, that's mainly dealing with perpendicular, but if we create the habit of looking at this one, we should be all right. Okay, now we have times the quantity x minus our x sub 1, which is a negative 3. All right, now we would prefer this, which is in point slope form, to be in slope intercept form. So we are going to have to take this equation and solve for the variable y. So we got to do a little housekeeping. First, we have a minus and negative back to back here. Once again, remember that always turns into a positive. So this is x plus 3 here. Now we can get this negative 5 over to the other side first, but remember, we would like to simplify either side if we could. And if we just look at this side over here, we have a number on the outside set of parentheses, which means we are going to have to distribute the negative 2/3 throughout the parentheses there. Okay? We have y minus 5. Negative 2/3 times x, number times a variable. We just slide those two together. Okay? Then we now remember, this is positive, even though there was negatives here. Remember, it ended up being positive. Now we have, though, a negative times a positive. And since we have opposite signs, it's going to be a negative. And then we have 2/3 times 3. If it helps to change both of them into fractions and make this 3/1, we should do that. So then we end up with 2 times 3 on the top, which is 6. 3 times 1 on the bottom, which is 3, which we do remember 6/3. We can go ahead and simplify that down to be a 2. Now, okay, there's nothing else I can combine over here because these are unlike terms. These are unlike terms. But the 5 and the 2 we can combine. So let's go ahead and move this negative 5 to the other side by adding 5 to both sides. In which case the 5's cancel out, leaving us with y is equal to negative 2/3 x. Negative 2 plus 5 is a positive 3. All right? In doing so, what we did was we created a new equation that went through the given point that they gave us, this negative 3, 5, and is parallel to the original equation, y is equal to negative 2/3 x, okay? Because they have the exact same slope, okay? They have the exact same slope. So if you want to pause the video at this time, you can try this problem out on your own. Okay, let's take a look at this. Now, students have said, now wait a minute, this isn't solved for y. Well, real quickly, we could solve this for y, and that's what we want to do first. Before we get the slope from the given equation, we want to make sure it's in y equals mx plus b form. Now, in this problem, really we need to get this negative 60 to their side by adding 6 to both sides. The 6's would cancel out, leaving us with y is equal to 3x plus 6. Now, some students will realize, well, moving that 60 to their side didn't change my slope. But we want to ensure that there isn't something that can change the slope. A simple negative or number in front of the y could change everything in this. Okay? So we always want to make sure before we get our slope, we have our equation in y equals mx plus b form. Okay? So if we look at the slope of this one, the slope is 3. Now, once again, we want to use the slope parallel. Okay? Parallel to this one. And remember, parallel slopes are exactly the same. So the slope we're going to be using for this one is 3. Okay? So just like on the last problem, let's go ahead and bring down our 0.48 and plug it into our point slope form. Okay? Y minus y sub 1 equals m times the quantity x minus x sub 1. Okay? So this is my x1, this is my y1 here, and that's my slope, of course. So we're going to end up with y minus 8 is equal to our slope, which is 3, times the quantity x minus x sub 1, which is 4. All right. We want to go ahead and get a little bit of simplifying over here, so we should distribute the 3 throughout the entire set of parentheses. We have y minus 8 is equal to 3x, 3 times x, push them together. 3 times negative 4, positive times a negative, different signs means negative. 3 times 4 means 12. And finally, to get the y by itself, get rid of the minus 8 by adding 8 to both sides. 8's cancel out, leaving us with y is equal to 3x. Negative 12 plus 8 is negative 4. Now, once again, we check real quick. This line parallel to this one up here. Yes, because they have the same slope. And we applied this 0.48. So that means that this point is on the given line. Y is equal to 3x minus 4. Okay? Okay, those are 2 examples for parallel lines. Now, before we flip this page over, let's look at perpendicular. Okay? Perpendicular lines are a little bit different. Okay, perpendicular lines are going to be a little bit different, a little bit more complicated than parallel lines. Okay, perpendicular lines form, where they intersect, they form right angles. Okay, they form right angles, aka 90-degree angles. Okay. Now, if we're having a tough time visualizing that at all, if we reference back to the notes that we did in the previous section real quick, or just any coordinate grid, if we take a look at the coordinate grid, we have the x-axis right here, and then the y-axis, okay? The x and the y-axes are actually an example of perpendicular lines, okay? because where they intersect, they form 90-degree right angles, okay? And actually, we'll have 4 90-degree angles because we have one in each quadrant, okay? Now, we have many examples of perpendicular lines throughout our room here. If we think of the ceiling tiles where the borders come together, those are perpendicular lines. We have lines on the cinder blocks on the walls or any posters, any boards. So really, there are tons of perpendicular lines around us and in our everyday world, okay? Now, I said before that we have a symbol for perpendicular, just like we do for parallel. The symbol we have for perpendicular is an upside down capital T. Okay, it kind of looks like 2 right angles put back to one another, okay? Now the most important part, the part that we have to use, slopes for perpendicular lines. For parallel, it was the easy one because they're exactly the same, so that's why they were matching here and they were matching over here. For perpendicular lines, it's a little bit different, okay? Slopes are opposite inverses. Opposite inverses, okay? Now, I actually was taught growing up to call it negative reciprocal, but I did get brought up that the students thought opposite inverses are easier to understand because when we say the term negative reciprocal, yes, we might understand that the term reciprocal means to flip the fraction, but students were getting confused on the term of negative. They thought, oh, that means that the perpendicular slope must always be negative. No, that means we want to apply a negative. But by saying opposite inverses, this seems to be helping out a few students. For instance, if we had a slope of 3/4 and we were looking for the slope perpendicular to it, first off, the opposite is referring to the sign. So since this is positive, we want to apply the opposite to this one. So the opposite of this would be negative. So positive, negative, they're opposites. Now inverses deals with the fraction 3/4, okay? If I did the inverse of it, basically flip or reciprocal, we would have 4/3, okay? These are perpendicular slopes because they are opposite, one positive, one negative. Inverses, their fractions are just flipped compared to one another, okay? Okay, and another way we can check if 2 slopes are perpendicular to one another is by simply multiplying them together, because every time we multiply perpendicular slopes together, we should end up with -1. So let's check that real quick. 3 times -4 is -12 over 4 times 3, which is 12, which does simplify it indeed to -1. Okay? And then I'll have students, they'll question, let's say we had another example here real quick. Let's say they said the slope was 5 and we tried to find the slope perpendicular to 5. Okay? Remember, any number can be written as itself over 1. Okay? Now we have a fraction. So since this is positive, the perpendicular slope would be negative. And to do the inverse of 5/1 would be 1/5. So even if it's an integer, we can quickly change it to a fraction to help ourselves out a little bit. Okay? Once again, for perpendicular slope, we want opposite inverses. So let's take a look at the final 2 examples of this part of chapter 2.4. Okay? Same instructions almost, except we're wanting to deal with perpendicular. Okay? We want a line that goes through this point and is perpendicular to the given line. So let's go ahead and focus on the first one here. Let's identify the slope of this line, which is the number in front of the x. This is that 5/2. Now we want the slope perpendicular to this one. Once again, opposite. If this is positive, this one has to be negative. Inverses. This is 5/2. Flip the positions. We will now have 2/5. So we have a perpendicular slope of -2/5. Okay? Now, besides that little part right there, we're going to bring down our point and do the exact same process we did previously. The only difference is we have to do a little bit of work to get the correct slope for perpendicular lines. But now, since we have point slope, we use point slope form. Y minus y1 equals m times the quantity x minus x1. Plug in what we know. That's the slope. This is our x1, y1. And plug in our information. Y minus y1 is 3 equals my slope, which once again, see, here's the big key difference. We want to use our perpendicular slope because it's -2/5, not the original. Okay, if we use the original, this is going to give us a parallel line. We want to use -2/5. Okay, -2/5. for our slope, times the quantity x minus our x sub 1, which is 4. Same process as the previous example. We have a number on the outside set of parentheses, so let's distribute. In which case that'll give us y minus 3 is equal to negative 2/5 times x, number times a variable. Let's just push those together. And then we have a negative times a negative, which is a positive. Fraction times an integer. Let's go ahead and change that integer to be a fraction. Okay? So then we have multiply the tops together to give us 2 times 4, which is 8. 5 times 1 on the bottom, which is 5. Then we want to get the y by itself, so we'll get rid of the y, or get rid of the minus 3 by adding 3 to both sides. In which case 3's on the left cancel out, leaving us with y is equal to negative 2/5 x. Now once again, just as a side note, hopefully a little bit of a review here, since we have a fraction plus an integer, just as always, we probably should change that to be a fraction plus a fraction. And keep in mind, in order to get add or subtract fractions together, we got to get common denominator. So we're going to have to multiply the bottom by 5, as well as the top of this fraction by 5. That's going to give us 8 over 5 plus 3 times 5 is 15. 1 times 5 is 5. Remember, that's still 3 right there. 15 divided by 5 is still the 3. Common denominator, we keep the common, so it's going to be 5 still. Then 8 plus 15 gives us 23. Okay? In which case, this is our y-intercepts. We want to go ahead and put that back into our equation up here because we were doing the work down here to finish this guy right out. So plus 23 over 5. Okay? And that is the line perpendicular to our original line up here. Zoom out here real quick. Perpendicular to 5 over 2, negative 2 over 5, and goes through the given point. Okay? And goes through that given point. All right? Let's go ahead and do this next one. If you want to try this one out on your own, go ahead and pause the video and try it. Okay, let's take a look at this one. We have a given point. We have an equation. We want to take the perpendicular slope. Okay, we want the line perpendicular to this one that also goes through this point. So the slope of this equation is negative 5. Okay, if we want the slope perpendicular, just like we said before, if we have negative 5 here, we can treat that as negative 5 over 1. And that should help us out in determining perpendicular slope. First off, if this is negative, opposite means this has to be positive. Since this is 5 over 1, the inverse of 5 over 1 is going to be 1 over 5. In which case, bring down our point that we had from before, the negative 6, 2. Okay, this is going to be my x1, this is going to be my y1. And let's go ahead and put our point slope into point slope form. Y minus y sub 1 equals m times the quantity x minus x sub 1. Plug in our information here. Y minus y sub 1 is minus 2, equal to our perpendicular slope, not the original, but the perpendicular, 1 over 5, times the quantity x minus our x sub 1, which is a negative 6. Okay? Once again, some housekeeping. We have minus and negative right here, so we can go ahead and change that to be positives. And still same process as before. We have a number on the outside set of parentheses, so we are going to distribute that 1/5 throughout the set of parentheses. We have y minus 2 is equal to number times the variable, 1/5 x. Then 1/5 times a positive 6. Okay, once again, integer, maybe change that to a fraction. So on top we have 1 times 6, which is 6. And on the bottom we have 5 times 1, which is 5. Okay? Finally, get the y by itself by getting rid of a minus 2 by adding 2 to both sides. 2's cancel out on the left, leaving us with y is equal to 1/5 x. Once again, if we want to combine these together, that's 6 over 5 plus 2 over 1. Since that was an integer, we just changed it to a fraction. Same thing we had to do on the previous one. We're going to have to multiply by 5 again. Okay? In which case, that's going to give us 6 over 5 plus 2 times 5 is 10. 1 times 5 is 5. Remember, that's still 2 right there, 2 divided by 5. Common denominator, let's keep it. 6 plus 10 on the top is going to give us 16. Okay, and that doesn't simplify any further, so we're going to go ahead and put that y-intercept up here in our equation. And there is our perpendicular line to the given line. Y is equal to negative 5x plus 2, and goes through the point negative 6, 2. Okay, and goes through that point, negative 6, 2. Okay? Now, real quick, I want to you do not have this on your paper, but we're going to have some problems where we're going to be asked, are we dealing with parallel? Are we dealing with perpendicular? Or are we dealing with neither? Okay, 3 possibilities here. So I'm going to give you 2 slopes. We got to decide whether or not we're dealing with perpendicular, parallel, or neither. Okay, so if I gave you this slope, you can pause the video if you want to test it on your own. Okay, for this one right here, first off, are they parallel? No, because they're not exactly the same. Are they perpendicular? Do we have opposite signs? Negative, positive. We have that, but do we also have inverse fractions? 5 over 4, 4 over 5. So they are flipped fractions and they do have opposite signs. So we do have perpendicular for this one, symbol for perpendicular. You can try this one on your own. Pause the video. Okay, let's test. Do we have parallel? Yes, we do, because we have the exact same slope for both of these. And once again, parallel is going to be, looks like 2 vertical parallel lines. Now, these are obviously easy because we're able to look at these pretty well and get through the problem. But now the question is, what happens when they give us sets of points? Okay, we are just going to make up some numbers here like that. Okay. Now, what we're told in this problem is these 2 points are on a line, these 2 points are on a different line. Are the lines parallel, perpendicular, or neither? Now, what we need to do, though, is before it was easy because I gave you the slope. Now we're going to need to calculate the slope. So go ahead and try that on your own. Calculate the slope of this line, calculate the slope of this line, and then compare the 2. Okay? Now, in order to calculate the slope, we've got to remember m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So for this one right here, okay, x1, y1, x2, y2, let's go ahead and plug in what we know. All right, and I'm going to write this over here because I have a little more room. Negative 6 minus 4 for the top over 5 minus 1 for the bottom. So in this one here, that's going to give us negative 6 minus 4, which is negative 10, all over 5 minus 1, which is 4. Okay. Now this can simplify. I think everyone agrees we can divide top and bottom by a 2 right there. Okay. So let's go ahead and do that, and that's going to give us negative 5 over 2. So that is the slope for the top one. All we need to do now is apply that same process to the bottom one here. x1, y1, x2, y2. Let's see what we end up with here. We have y sub 2 minus y sub 1. It's going to be 2 minus 4. X sub 2 minus x sub 1. It's going to be 3 minus 5. 2 minus 4 is a negative 2. 3 minus 5 is also a negative 2. And then anything divided by itself is 1. So our 2 slopes that we have here, okay, we have m is equal to negative 5 over 2, and m is equal to 1. First off, are they parallel? No, because they're not exactly the same. Are they perpendicular? No, because even though one's negative, one's positive, it follows that rule, it also has to follow the rule of it has to be inverses one another. And the inverse of 5 over 2 is going to be 2 over 5, not just 1. So that means here we actually have an answer of neither. Now that's not saying that these lines don't intersect. Remember, that's parallel lines. These lines intersect, they just don't intersect to form 90-degree angles. Okay? All right, that concludes the part we're going to deal with 2.4 today. Make sure that we're getting caught up on not only this assignment, but any missing assignments that we have. And as always, if you have any questions, send me an email.